Welcome to this explainer. We hear it absolutely everywhere. Wind and solar are the cheapest energy sources on Earth. But in our modern world, just generating cheap power isn't enough anymore. We have to be able to deliver it continuously. So today we're going to demystify the true cost of making renewable energy reliable 24/7. We are shifting our focus from the simple cost of generation to the complex but honestly fascinating cost of continuous delivery. Here is our roadmap for today. We're going to cover the 24/7 power problem, the firm LCOE metric, beating the battery wall, the cost of firm power, and finally, the new capacity race. All right, let's jump right into section 1, the 24/7 power problem and the limits of cheap generation. So, can renewables actually power a 24/7 world? It's kind of the ultimate question, right? Wind and solar have achieved something truly incredible. They are literally the cheapest energy sources in history. But there's a fundamental catch that we all know. The sun eventually sets, the wind occasionally stops, and yet our modern infrastructure never, ever sleeps. And let's be real, that infrastructure is only getting hungrier. We're talking about AI, massive data centers, and advanced manufacturing driving a huge surge in demand for uninterrupted, round-the-clock power. As the world demands more and more continuous electricity for high-stakes operations, everything from running complex AI workloads to keeping hospital life support systems online, we absolutely have to find a way to bridge that gap between variable weather and constant demand. Moving right along to section 2, the firm LCOE metric, and why we desperately need to change how we measure cost. Okay, so for years, the industry gold standard has been the levelized cost of electricity, or LCOE. But here is the problem. LCOE only measures the cost to generate power right at the plant level. It completely ignores the cost of making that power dependable for the grid. It tells you how cheap the power is when the sun is shining, but conveniently leaves out the cost of keeping the lights on when it isn't. Actually, it helps to think of system electricity costs like a giant onion. To get the full picture, you really have to peel back from just that inner layer of plant-level generation. You have to include the grid-level system costs, things like grid connection, network reinforcement, operational flexibility, and, most importantly, adequacy and reliability. Which brings us to a total game changer. We need a new metric, and that is firm LCOE. What this does is calculate the real, fully loaded cost per megawatt hour of reshaping variable weather into a continuous 24/7 power supply by combining renewable generation with storage. Basically, it answers the question, what does it actually cost to make renewables reliable? And honestly, what you're buying with that extra cost, that firming premium, is a vital transformation. You start with wavy, unpredictable generation. But by strategically adding battery storage and overbuilding your capacity, you flatten out those peaks and valleys into a rock-solid, constant stream of electricity. And that flat line, that is exactly what the modern grid needs to survive. That brings us to section 3, beating the battery wall. This is all about the economic trap of relying 100% on batteries. Now, you might be thinking, hey, let's just buy a ton of giant batteries to store all that extra solar. Sounds simple enough, right? Well, when you compare a strategy that relies exclusively on batteries against one that cleverly mixes batteries with extra solar and wind generation, it reveals a massive difference in the final cost. Just look at the trajectory for a hypothetical site in Las Vegas. If you try to push past 86% reliability using just batteries, the costs literally explode into what's known as the battery wall. But by deliberately overbuilding your solar generation alongside those batteries, you completely flatten that cost curve out. It turns out building extra solar panels is actually way cheaper than buying massive batteries to catch every last drop of power. And watch what happens when we toss wind into the mix alongside solar and storage. The costs drop even further. Because wind and solar naturally peak at totally different times, they actually act like puzzle pieces fitting together. They smooth out those multi-day weather lulls, which drastically lowers the amount of expensive storage you need overall, structurally lowering the cost of firming. All right, section 4, the cost of firm power. Let's talk about plummeting prices and massive market disruption. The real hero making all of this possible is a staggering number, 93%. Driven by an unbelievable 93% drop in battery energy storage costs between 2010 and 2024, the fundamental math behind round-the-clock renewables has just been completely rewritten. And the crazy part, the costs are still falling. We are looking at a projected 48% free fall in firm LCOE from 2025 to 2035 across major global markets. Just look at that steep downward slope. This massive trend is expected to bring the cost of fully firmed 24/7 renewable power to under $50 per megawatt hour in the best global locations by 2035.
So why does this matter right now? Well, looking impartially at the market data, firm renewable power is now demonstrably undercutting the cost of new fossil fuel plants in key regions. In China, firm solar with 90% reliability sits at roughly $30 per megawatt hour, while new coal is estimated at $70 to $85. Over in the US, new gas combined cycle is around $102, while firm solar plus storage projects in places like the UAE are hitting $70. This is fundamentally altering the global competitive landscape.
Which perfectly tees up our final section, Section 5, the new capacity race. Speed and stability as the ultimate advantage. Because in this new era, moving away from fossil fuels isn't just an emissions strategy, it's a tactical business advantage. Hybrid renewable systems are winning on sheer speed and stability. They can be deployed incredibly fast in just 1 to 2 years. They offer amazing modularity, scaling right behind existing grid connections. They offer complete immunity, insulating businesses from international fuel supply shocks. And precision, seamlessly meeting strict corporate hourly matching requirements. And look, this isn't just on paper. Mega projects like the Al Dhafra complex in the UAE are literally doing this today. They are pairing 5.2 gigawatts of solar with massive battery storage to deliver a firm 1 gigawatt of clean electricity. That is equivalent to a traditional thermal power plant, delivered continuously at an estimated cost of just $70 per megawatt hour. We are absolutely already delivering massive continuous power at highly competitive rates. So as the data center boom accelerates and our appetite for uninterrupted power just skyrockets, the rules of the grid are fundamentally changing. Thank you so much for joining me on this explainer. I want to leave you with this one thought. In a world where speed to build, modular scalability, and absolute price stability are the new currencies that define the winners, how will our traditional energy infrastructure adapt to survive?